So this is Algebra 2 with trig 7.5. We're going to apply the properties of logarithms. So what we want to look at is recognize that we're multiplying what we're trying to take the base of. We're looking at two factors of what we're trying to take the log of. We can also write that as the addition of two separate logarithms. As long as they have the same base, we can use that property to take one logarithm and write it as two. We use addition if we have factors of what we're trying to take the logarithm of. For the second one, we're taking a logarithm of a fraction. So when we're taking a logarithm of a fraction, we are going to subtract. Just like we did when we talked about exponents. We subtracted the exponents if we were doing the same base. Dividing the same base, you subtract the exponents. That's the same idea that's going on here. When we talk about exponents, we raise a power to the power. We multiply exponents. Well, that's the same idea. We're going to bring that power to the front of its own logarithm. And we would multiply that logarithm. These properties of logarithms, we will use them going in both directions. Okay, it'll be called expanding when we write them as multiple logarithms, and it'll be called condensing when we go down to a single logarithm. So in some cases, if two logarithms have the same base, it helps us come up with a better answer if we can write it with a single logarithm. So we're going to use some of those properties here. Notice that with this set of examples, we know that the log base 5 of 4, at this given moment, we have no way of calculating that. You can't use your calculator, at least with the common log. That's the log button that's next to the 7. We cannot use that key to answer this question because this has a base of 5. All right? You can't use that key. I know many of you tried, but it doesn't work. This is a base of 10 on the calculator. This is a base of 5. But here in our directions, the given information, they tell us some information. So we recognize with this logarithm that we are dividing. So our property that we learned about is log base 5 of 4 minus log base 5 of 9. So now we can separate those and write them with the decimal versions that they give us from the given information. So the only calculator work we're doing here is adding or subtracting, in this case, subtracting decimals. We're not using it to calculate logarithms of numbers. So in this case, it was pretty clear. We had a 4 and a 9. The numbers they were given to us were 4 and a 9. Now we look at the second one, and it is a 36. Well, that's not 4, that's not 9. But isn't 36 4 times 9? There's many different ways to get 36. 18 times 2, 72 divided by 2, 6 times 6. But we don't know the logarithm version for any of those. we know that the log base 5 of 4, we know what that is, and we know log base 5 of 9 from the given information. This is multiplication, so now we're going to write it with addition. Now, because we have broken this down into log base 5 of 4, we can use the decimal version of 861, and log base 5 of 9 is the decimal version of 1.365. And we can do our basic calculations with our calculator. 0.861 plus 1.365. We're going to get 2.226. So there are steps, there are things to show for us to be able to come up with that calculation. We don't just write the decimal. We have to show our steps for where those calculations came from. Now think about this one. How could we use 9s and or 4s? Well, I know that 81 is 9 squared. So you don't have to use the 4. 9 or 4, or 9 and 4. But in this case, we won't use the 9. We won't use the 4. We'll just use the 9. We learned before that if we have our exponent, we can put it in front of the logarithm. So now this is log base 5 of 9, which is 2 times 1.365. Two times 1.365. 2.73. Let's see if we understand what does this 2.73 number mean. When you look at the value of your question, the base, log base 5. 5 to what power equals 81? That's the question. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. So you know it's not 5 to the third power. It's a little bit less than that. And that's where we came up with our 2.7. That's a reasonable type answer. Back here, 5 to the second power is 25. 36 is more than 25. So our answer is going to be more than 2. But it's not as big as 125. So this is not as big as 3. So now you go ahead and try these. And you can pause your video and you can check your answers out after you get those completed. All right, so here we have division. So you'd say log base 6 of 5 minus log base 6 of 8, 0.898 minus 1.161. We calculate that out. And we get negative 0.263. Here we have 40. So we're using 5s and 8s. So 5 and 8 will multiply to be 40. So 5 times 8 would be a good number to use, which means that we are going to use addition. Log base 6 of 5 plus log base 6 of 8. So we got our 0.898 and our 1.161. So we're going to add these. And we get 2.059. Now we look at our last one over here. Following our examples that we had, this is the same thing as 8 squared. You could even do 8 times 8. Okay, 8 times 8, and then you would write it twice. Log base 6 of 8 plus a log base 6 of 8. If you write it in this format, that means 2 times log base 6 of 8. So either way you think about it, whatever works. So 2 times 1.161, we get 2.322. All right, if no questions, we move on to expanding and condensing. Now it gives a little description in here about what expanding is. Okay, expanding is writing multiple logarithms. You're going to have several logarithms written when you expand. Condensing, smaller. You're going to shorten it up. In condensing, your final answer should only have one logarithm as part of it, not multiple logarithms with it. So our next set of examples are going to be based off of that. We're going to look at expanding, and we're going to expand something that looks crazy like that. So you could say that you're going to simplify it down. You're going to break it apart. So one of the things you see here is a fraction. It is a logarithm of a fraction. So we're going to write it as log base 3, 7 square root x minus log base 3, y to the 4th. Now here with the 7 square root x, we can break that apart into multiplication. Well, it's already multiplication, so I won't show it as multiplication. I'll show it as addition. Then we have the minus log base 3 of y to the 4th. So from this point, we still have our exponent. We can write our exponent in front of the logarithm. But what can we do with this square root? Can a square root be written in a different way? Is there an exponent that represents a square root? x to the half power, that is the same thing as the square root. We're going to write the 4 in front of its own logarithm. And now we can write the half in front of its own logarithm. Nothing else we can do with log base 3 of 7. And now there's nothing additional we can do with 4 times log base 3 of y. Now that is condensed. Well, I said that backwards. That is expanded. We expanded it apart. We wrote multiple logarithms from that single logarithm. Okay, we're going to try it again. So you go ahead and take that problem. Think about what needs to be done. So now we'll take a look at log. It's a common log because there is no base written. So it's a base of 10. 7y cubed minus log 4x squared. Here we have two factors. We have 7 plus log y cubed minus, now here you've got to be real careful because we're subtracting this whole logarithm. But if you write this logarithm into 2 parts, you need to be sure to subtract that whole 2 parts. You need to subtract them both, so you've got to have parentheses there. Of course, the 3 can go in front of its logarithm. Now we can distribute this negative into the parentheses. So it's still minus the log of 4, but it's also minus 2 log of x. All right, now we can look at condensing. We're going to write this down to a single logarithm. This has multiple logarithms already. We're going to write it down to a single logarithm. We bring that exponent up first. So we have log of 2 plus log of 3 cubed. And we haven't touched the log of 9 yet. Well, this is the plus between the logarithms tells us that this is multiplication. Multiplication of our 2 terms that we're trying to take the log of. So this is log of 2 times 3 cubed, which is 27, minus log of 9. Well, that's turning into log of 54 minus log of 9. Log of 54 divided by 9, because you have a subtraction between 2 logarithms. You don't write the log twice. Some people think that you're going to do log of 54 divided by log of 9. Right? Do we all agree? Like right now? No, you'd never do that. That is something we're going to do in the future, but for a different reason. So understanding why you don't do it here. Okay. This, we're using the properties, the quotient property, and that only has a logarithm written once. So now this can be turned into log of 6. And if you wanted to test all this, you could test it out because there are no variables with this one. You could say log of 2 plus 3 log of 3 minus log of 9. Let's just be sure that we have our parentheses in here where we need them, and it doesn't mistakenly read that as something else. Okay, and we get a crazy decimal. Well, we could go down and do our final crazy log base. It's a 10. It's a common log of 6, and that should have the same exact decimal. So with any of the other steps in between, they'd all have the same decimal. But if you're trying to find out, did I do something right? Is this accurate? The answer is yes. But we're not looking for the decimal. Don't put that decimal on your answers for your homework. We didn't use calculators to do any of that. All right, this is the first one that has natural log. That's an LN. It's not IN. It's not in. It's natural log. It's the same thing as a logarithm. This just has a base of E. It's irrelevant in any of this. You won't see the E the entire time. So we use the 2 as the exponent on the X. Then we work left to right. So these 2 are adding, so we're going to work with those as multiplying. Then you're still subtracting natural log of Y. Now you have a subtraction sign. You only write the natural log once, and you divide what you're trying to take the natural log of. Next, we're going to talk about something somewhat new. We haven't done this, called the change of base formula. Okay, with the change of base formula, we are changing it from a base that we're not really sure about into a base that we are much more comfortable with. When we look down here to this value, 6 to what power equals 11? We cannot get our log button to do that. Many of you try. You think that you might do log base 6 of 11, right? That's not how it works. Nope, nope, nope. It's not 6 to the 8th power equals 11. Not that. Okay, we can't use that button. So we have to use something called the change of base formula. It's got a little magic to it. It's the log, and notice that you have your 2 parts to your logarithm. You have what you're taking the logarithm of, and you have the base. It's the log of M divided by the log of B. You can change it into any base you want. It's kind of magical. Change it to any base that you want. Your book will often have a C written here as your base. But that C is going to be a 10 because that's what your calculator can do. So you're never going to change it to anything different than a 10. But could you change it to an e? If you changed it to a base of e, you'd write that as a natural log of m over the natural log of n. Notice here, you're writing the natural log or the logarithm, you're writing it twice. It's not the quotient rule where we only wrote it once. So this is where people start to have confusion on what the correct notation is. So try to keep that part straight. Only to change a base formula do you write the logarithm twice like that. So let's come down here. Let's give this a try. So we have log 11 over log of 6. So I take my calculator, I can say log 11, put that in parentheses, divided by log of 6. I can close them if I want to and hit enter. 6 to the first power is 6. 6 to the second power is 36. So 6 to the 1.3 might actually be 11. That seems reasonable, much better than 8. Right? Now, these calculators do cost $100. Can't they do this change the base thing? And the answer is yes. They can change the base. And there's different locations that we could find this in. But where I usually find mine in, you've got catalog down here at the bottom. Catalog. So it's written in blue. So you have to hit your blue button first. Second, then you hit the catalog button, and that pulls up the actual catalog of all the little fancy things the calculator can do. Now, if you scroll down, by hitting your arrow down key, you're going to feel like you have to go forever. You're going to go all the way down to logarithm, L. So a quick way to get to L is to hit the key with the green L. All right, so that would be the parenthesis key. And that's going to jump down to the L's. Well, that's handy. Then you can arrow down a few more times until you get down to the bases. And there it is. There's your log that has a base that you can change. So log base 6 of 11. There you can do it, and there you can check your work. Okay, so the change of base formula and the calculator way of changing the base, you're of course going to get the exact same answer. Okay. It's clearly faster just to do that. Taking your calculator and saying log 15 divided by log of 3 seems better than going to the catalog and going down and changing it over. So to round it to the nearest thousandth, you have to go over to the 10,000th and round. Since that's 5 or bigger, we make that 465. All right, your turn to work on these expanding, condensing, and evaluating. So we have division. So we're going to write this as x squared minus log of the cube root of y. We have an exponent, so we're going to write that in front of its logarithm. Now this is the cube root of y. The cube root of y, remember, can be written with an exponent. So that's to the 1/3. And we can bring it and put it in front of its logarithm. And there's nothing else that you can do there. You cannot say 2 minus 1/3. Logarithms aren't the same. Here we're condensing, we're bringing it together. So we have log of 9 plus log of 2 cubed. So that is 9 times 8, which is 50, 9 times 8, which is 72. Minus log of 3. Then subtraction tells us to divide. So we get log of 24. And then we can use the change of base formula to approximate what this would be. Log of 50 divided by log of 7 gives us approximately 2.01. All right. Now we're getting a little close on time. Our last question. I'm just using a formula. The formula is 10 log of your sound, and your sound is 10 to the 2.8. That's the sound of electric guitar, divided by the barely audible sound, which would be 10 to the negative 12. Couple different ways we could work this out, but the bases are the same, so we can subtract exponents. When you subtract the negative, you're actually adding. All right, so that's 2.8 plus the 12. So that's going to give us 10 to the 14.8. Now we're going to bring that in front. So it is, well, let's not say it in that direction maybe. Let's say that these bases are the same. So this is 10 times 14.8, which is 148 watts. I know that was pretty quick. Yeah. Ever have any questions, be sure to ask. Looking back at our work, it looks like we needed to have the 5 on those also.